Alright, so we're going to try and prove this is a parallelogram by first proving I have two congruent triangles. So always when you start a proof, what do you give? What do you write down? The givens?
Given.
Okay. One of the things that given is that angle B is
Angle D.
congruent to angle D. Angle B is congruent to angle D.
Given.
That was given.
Guy.
That was given to us. Okay. What's this little arrow thing here mean?
The sides are
Parallel, right? So
BC
that's
and AD are parallel.
BC is parallel to AD, given. So BC is parallel to AD, given. Alright, so I wrote down the givens. I'm trying to prove triangles are the same. They do share a common side, AC, don't they?
Yep.
So can I say that AC is
Yes.
congruent to AC?
Yep.
Remember that property?
Yep. That's the
We got it.
reflexive.
Reflexive property of congruence.
Got it.
So AC is congruent to AC by the reflexive property of congruence. So I'm going to add a mark then for that. I don't have enough information yet. I know they have a congruent side, and I know they got a congruent angle, but I don't have anything else written down yet. We do have we do have parallel lines here, right? So I have a parallel line here, I have a parallel line here. It's cut by a transversal here. So wouldn't that angle have to match this angle because of alternate interior angles?
Wait, so it's so angle C guy.
Now when I name this angle right here, I can't just say angle C because there's three different angles located at point C, so I have to use three letters, right? BCA or ACB, both of them are fine, guys. Okay, so angle BCA, that'd be referring to that angle right here. Angle BCA is congruent to angle DAC. Yep. Angle DAC, and that's because of alternate interior angles are congruent. That's my angle apostrophe S, angles. Okay, just to clarify my chicken scratch handwriting there. Okay. Alternate interior angles are congruent. Now, do I have enough information to state that the triangles are congruent?
Yeah.
Yes, by what?
Angle side.
Angle side. Careful. This side is not right in between the two angles that we know. See how it goes angle, angle, then side? If this side was marked congruent with that one, then you could go angle, side, angle, but it's not. So it's angle, angle, side.
Oh crap.
So triangle ABC. Order is important here. Triangle ABC. Triangle CDA. Angle, angle, side. Yep. Not quite yet. Gotta say one more thing first. Okay? Because the triangles are congruent, aren't the triangle's parts congruent to the other triangle's parts? So wouldn't CD now be the same as AB?
Yeah.
And wouldn't BC be the same length as AD? And what's the reason for that? Once we know triangles are congruent, why do we know their corresponding parts?
CDP,
CP, CTC. Yep, corresponding parts of congruent triangles are congruent. You can write all that out, or you can write CP, CTC. Corresponding parts of congruent triangles are congruent.
No.
I'm going to write both of those things. BC is congruent to AD. I could write these two things on separate steps, guys. I'm just going to put it on one because I'm getting close to running out of room. So BC is congruent to AD, and BA is congruent to CD. And the reason is CP, CTC. So now I know this side was congruent to this side. This side was congruent to this side. Now, ABCD is what? A parallelogram. Because opposite sides are congruent. Right? Opposite sides are congruent. We haven't really said anything about this whole angle here being the same as that whole angle there, so we can't quite use the opposite angles one. Alright? But we do know that these sides are equal, therefore it is a parallelogram. So ABCD is a parallelogram because opposite sides are congruent.
That's a lot of steps.
Yep.
It's a big proof.
Alright, so any questions on this? Anything right now that you can see? I'll give you some more to try.
Are they all going to be where we have to prove their parallelogram?
Yep.